Okay, so what is a series? A series is where we add the terms of a sequence. So the terms have some kind of relationship or pattern to each other, and the related series is where we add them together. So an arithmetic series is formed by adding the terms of an arithmetic sequence. There is a sequence 1, 3, 5, 7, 9, and the series is 1 plus 3 plus 5 plus 7 plus 9. So then we can find the sum of the terms, okay? And there's a notation for that. So capital S for sum, kind of makes sense. So the subscript tells you how many terms you're adding. So this 3 means we're adding the first 3 terms, right? So this 2 means we're adding the first 2 terms. S1 is the same as term 1, okay? So that's always going to be the same. But then to get S3, you add the first 3 terms. To get Sn, it means you're adding from term 1 up to term n, okay? So that those n's match up. So the sequence the series 1 plus 3 plus 5 plus 7 plus 9. Then what is S4? Okay, so we already know S3, and rather than adding all of the terms, if we already know S3, we just add the 4th term. Okay, so these add to 9, so now add 7, that's going to be 16. So now these add to 16, add 9, that's going to be 25. Okay. So what is Sn? What's a formula, a fast way of coming up with formulas? We'll take a look. 1, 4, 9, 16, 25. Those are perfect squares. Okay, so 25 is 5 squared. Well, 5 was the n value. 16 was 4 squared. Well, 4 was the n value. So this is n squared. Okay? We're not going to look at the teacher demonstration. It's no longer available actually on YouTube. But because we're actually going to learn the formulas. Today it'll be the formula for S. Actually, you know what? I'm going to show you a little bit. I don't have the video, but I'm going to show you a little bit of how that formula comes about, because it's kind of interesting. So for an arithmetic, so I'm just going to go to a clean screen. You do not have to copy this down. But let's think about, so a mathematician named Gauss, many years, well, many years ago, of course, but when he was like, I think they say the age of a grade 2, so what, like 7? He was super smart, right? So he was coming up, looking at a series kind of like this. Adding up, he was looking for a fast way to add up numbers from 1 to 100 without going, okay, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, etc. He noticed that if he wrote down the same series underneath so that he lined up the terms, because you have 100 terms, he noticed that if he added each column, he would have 101. Oops. And 101, and 101, and 101. Okay, so that made it way easier for him, right? So how many 101s does he have here? So this is equal to, so the sum, so if we call this S equals that sum from 1 to 100, then this is S, and we add those together. Then that means 2S is equal to those. Okay, we're adding the columns. So that means the sum of one of the series is a half of 101 added together 100 times, right? So 100 times 101. All right, that would be the sum of the series. So then that would be, again, half of 10100. Again, they didn't have calculators back then, right? So that would be 5050. I think. Okay, and so he looked for those patterns and found out what to do there. So in terms of a general case, so if we have, so this was S of 100 terms. So S of n terms was a half because you're adding two of them, multiplied by the number of terms, n, okay, multiplied by the sum of the first term and the last term was 101. So first term plus the last term, okay? And so you'll often see this shown as n over 2 times t1 plus tn. That's the sum of n terms of an arithmetic series. One version of it. Another version, because it's arithmetic, right? We already know that Tn is T1 plus n minus 1 times the common difference. So if we substitute that in, we get T1 plus T1 plus n minus 1 times d, right? There's your Tn. And if we collect like terms on that, we get 2t1 plus n minus 1 times d. So that is the other version. So there are two possible versions you can use for the sum of an arithmetic series. And really it just depends on what information you know. No matter what, you have to know how many terms you're adding, n. No matter what, you have to know the first term. Okay? In this one, if you knew the nth term, that would be faster. If you didn't know the nth term, then there's your n, so you have to know that already. If you knew the common difference, you could calculate Sn. So really depends on what information is given. So there's two versions. But that's really how the formula works and where it comes from. Okay? So, question here. And when do you use the second version? Basically, if you don't know the value of your last term. So if you're looking for the 50th term, but you don't know what the 50th sum, but you don't know what the 50th term is, you would use the second version. You'll end up using this second version more often. Okay? It's more the first version that's more of the exception. Okay? All right, so let's go back to where we were. All right, so there we go. So it says use this formula if you know the number of terms and the first and last term. Use this formula if you know the number of terms, the first term, so those are the same, and you know the common difference here. So these are the difference between them. So let's practice. So it says for the arithmetic series, 6, 11, 16, 21, determine the 50th term. So term, it has nothing to do with sum. We just want to know T50. Okay, so in here, our first term is 6, and our common difference, well, 11 minus 6 is 5. 16 minus 11 is 5. So now our 50th term is 6 plus 50 minus 1 times the common difference. Okay, so that's 6 plus 49 times 5. So what's that? 245 plus 6 is 251. then determine the sum of the first 50 terms. So now S50, okay, choice of which ones. So in this case, if we hadn't done part A, I would have used S50, the second one, because I know my common difference, I know the number, I know my first term, okay? But because I already found the 50th term and I'm looking for S50, I'm going to use the first version. So 50 over 2 times the first term plus the 50th term. Okay. So 6,425. Okay. Next one, if the first term in an arithmetic series is 12 and the last term, so this is a finite series, last term is T21, is 172. So that means there are 21 terms in the series. Determine the sum. All right, so we know here T1, if you want to write out what you know, T21 equals 172, N equals 21, then do so. So now S21 is 21 over 2 times 12 plus 172. Again, you're going to use the first formula because this is your last term. If I were to try to use the other one, I'd have to find the common difference, and I can't. Okay, I think there was a question, so give me a sec here. Okay. So now you can do all of that in your calculator. You can, you can simplify it if you want, but I just need to see the number substituted. If you don't show me this, you're not going to get full marks, okay? So if you want to show this, that's 184, and then you can divide or do whatever, but have to have this. Okay. So next one, determine the sum of the arithmetic series given there. Notice how there's a lot of negatives and subtracting because the first term is negative and the common difference is negative. So first term is negative 16. What's the common difference here? You're subtracting 2. Okay. Negative 18 minus negative 17. Okay, just give me a second. Okay, so taking a look at this one, we know the last term, so we know the first term and the last term, but we don't know what term number it is. Right, so Tn equals negative 284, but we don't know what n is. So we can't use either formula. You have to know how many terms in order to use either of those formulas. Okay, so we're going to need to find out how many terms there is. So this is very similar to a question that we did back in arithmetic sequences. Which term number is this? Okay, so Tn is the first term plus n minus 1 times the common difference. And we know that that's 284 in this case. So then you solve that for n. So negative 284 plus 16 minus 2 is negative 270. N cannot be negative. Never, never, never negative. So if you end up giving me a negative value, you did something wrong. Okay, so N is 135. So now we can use either formula for S. I'm going to use the first one because I know that value of the last term. So S of 135 is 135 over 2 times the first term plus the last term. Don't forget about the negatives. Okay, so a sum can be negative, particularly for sure if all the terms are negative, right? So, but n cannot be negative. Okay, next one, determine the value of n for an arithmetic series. If you know the first term, the nth term, and the sum of those n terms. So we don't know how many terms there are, but we know the term value of the last one and the value of the sum. Okay, so if these match up, okay, then we can use that first formula. So Sn equals n over 2 t1 plus tn. So we're given t1, we're given the nth term and the nth sum, and we're asked to find out what n is. So that's our only unknown. So this one's pretty straightforward. Just substitute in. Okay, and solve for n. So n equals 18 when you solve that. All right. Next one, determine the first term. So we're looking for T1. Arithmetic series, we're given D and S10. So n equals 10, and we're given these values as well. Okay, and we're looking for the first term. So if you think about the first form of the formula, this one, we would need to know the 10th term. But we don't know that, and we would need to know the first term in order to get it. So that's not going to be helpful for us. We're going to need to use the other form. Okay, because we're given n, we're trying to find T1, we're given S10, we're given n, and we're given the common difference. Okay, so we know everything except for T1. So we just substitute in. Always make sure with your D, put brackets around it, even if it's positive. Okay, because it looks really weird to have brackets and then just a 12 there. We never show it like that. And it, certainly if it was negative and you didn't put brackets, that would be wrong, because that looks like a subtracting. Okay, so 9 times 12 is 108. You can expand out, you could divide by 5, however you like to solve that. Fastest is to divide by 5. And this is actually a small enough that you could test it out, get 10 terms, and then add them together, right? You could go, okay, negative 18 plus 12 is negative 6, plus 12 is 6, plus 12 is 18, plus 12 is 30, etc. I mean, if you really wanted to, and then add them together. Okay. Then the next one, you're actually given a formula for the sum of a series. Okay, so basically they've put the values in and simplified it. Okay, so if you think about, just think about the form of this sum. This one, if you knew T1 and D, if you expand this out, you're going to get an n squared, right? N times n. So this, for some value of T1 and D, could end up being simplified to this, okay, so in that form. So we want to find the first 4 terms of the series. So remember, S1 is equal to T1. Okay, so let's find S1. So that'll be 1 squared plus 2 times 1. Okay, so that's 3. So we know this is 3. Okay. S2 is going to be 2 squared plus 2 times 2. That's 8. Okay, now be very careful. S2 is 8. That is not the second term. That's the second sum. So to get the second term, we take the first term, okay, and add the common difference That's right. To get the second sum, we add the first term and the second term to get 8. Okay, so S2 is 8, and it's equal to T1 plus T2. Right? So if we know that T1 is 3, therefore T2 has to be 5. So you've got to work backwards. Then S3, well, if we know it's arithmetic, really you can already tell. That means that T3 should be 7, because 3 plus 2 is 5, plus 2 is 7. But let's check it out. So S3 is 3 squared plus 2 times 3. 9 plus 6 is 15. Okay. So S3 is 15. That's equal to, basically it's equal to S2 plus the third term. So 8 plus T3, okay, has to give us 15. So therefore T3 has to be 7, which is what we predicted anyway, right? You keep adding 2. So from there, I'd say T4 equals 9. All right? So always remember that. S1 and T1 are the same value. S2 is T1 plus T2. It is not the second term. So S's are different from T's. If you get them mixed up, you're in trouble. If you turn over the page in your booklet, there's some extra questions. The answers are there. I'm just going to choose... Okay, so question 5 is very similar to what we just did. We did something similar to 4 already. Okay, so we're going to do question 3 together. So on the back page, question 3, it says T2 is 40, T5 is 121, find S25. Okay, so for sure in this one, I'm going to use the form where you don't need to know the 25th term, because I don't know what it is. Okay, so I'm finding this, so equals what? Obviously n equals 25, so I have that. I need to know what T1 is and the common difference. So I'm going to need to do it from this. Okay, now in this case, these are small enough that you could write, okay, there's term 1, there's term 2, 3, 4, 5. Okay, and then to get your common difference, then that would be 1, 2, 3 D's is 121 minus 40. That's how one of the methods, I did it in green last week. I call it the green method. So that is, what's that? 81 over 3, which is 27. Okay. And so therefore T1 would be 40 minus 27, which is 13. Now if you didn't do it that way, you can use T5 would be, actually I wouldn't do a system, I'd then change this to T1 and T4 and go from there. Okay. But no matter what, you get your D value, and then figure out what your T1 is. You can really do that whole calculation in your calculator. Please make sure you show me the substitution. But I would probably do the inside part, like do 2 steps, right? So I gotta do it from my computer here. I'd go 2 times 13 plus, do 25 minus 1 in your head, 24 times 27 is 674. Okay. Hold on one sec. Just wait outside, okay? And then we'll multiply this. Okay, so that times 25 divided by 2. So 8,425. Okay. And that's it.